That's that quest with the door. The door. And then with the only thing I remember.
Welcome to the Space Vehicle Mock-up Facility. The floor down below us is where astronauts learn how to live and work in space.
But this area of Building 9 has the space station mock-ups.
Astronaut Mike Possum points out a few of the training units you can see here.
These are actual training units that we use a lot for crew training. The engineers use these to go in and make sure that new equipment's going to fit when we fly it up to the space station itself. This is actually a working laboratory that you're looking at here. The pieces of the space station are spread about on the floor. Most of them are roughly in the configuration that we have in space, but because we're limited to the flat floor, there's some things that are laid out a little bit differently here, but it gives you an idea for the sheer magnitude of all of these elements of the space station. One of the big ones right in front of you is the U.S. laboratory, and inside that are most of the equipment and the racks, just like we have it in space. We use these for training different types of space station procedures. We go in and practice the logistics of what it takes to move things from one end to the other. A little bit over to your left is the space station airlock. I've personally spent hundreds of hours in there as we practice all of the preparation for getting all of our equipment together and getting into our suits to head out the door. This is the one place where we really have everything put together and we can practice just like we're going to fly.
Astronaut Bob Cabana.
The U.S. laboratory connects to Node 1 that connects to the Russian segment of the space station, the functional cargo block, Zarya, and then the service module, Zvezda. Zvezda means star, Zarya means sunrise, and Node 1 is Unity, which binds the Russian segment to the U.S. segment.
Alright, ladies and gentlemen, we're going to be heading to our second stop here in Building 9, or RMS. The RMS is manufactured in Canada, so it is also known as the Cannon Arm. While in space, the Cannon Arm can lift objects weighing thousands of pounds very easily, but once brought back to Earth, it can't even lift its own weight. So to help train our astronauts, we have constructed a larger, stronger working model that we will see in just a moment. To the right and behind the FFT are two nose portions of the shuttle orbiter. These are the crew compartment trainers, or CCTs. The CCTs can be rotated into both vertical and horizontal positions for launch and landing procedures. Both the CCTs and the FFTs are high-fidelity mock-ups, which means everything inside is
Yaw, pitch, and roll as well.
The Building 9 station robotic manipulator simulates how we do operations on board the International Space Station. And in order to do that on Earth with the gravity that we have here, we have to use either things like balloons filled with helium, or we use very lightweight equipment that this arm can push, and we usually use wheels or ways to slide it across the floor. So we can move the objects that are the same size that they'll be in outer space. We just can't move them in the same fashion, so we kind of have to trick the simulator to make it look like we do when we do it in space. I've spent numerous hours in training learning how to operate the space station arm. We have basic training to learn the basic concepts. We also go to Canada, who are the arm builders, and we spend a lot of time, a couple of weeks there, and all we do is study the robotic arm and work with it and play with it using simulations. Then we come back here to Houston and we even double that and triple that amount of training so that we really know what we're doing when we get into space.
The large blue structure in the back and on the right is the docking simulator. It requires careful skill and training when docking something as large as the International Space Station and the shuttle orbiter. Whenever you see a spacecraft on TV, it looks as if it is just floating. However, it's actually traveling at a speed of 17,500 miles per hour, roughly 5 miles per second. This concludes this portion of the tour. Follow your tour guide down the
Bila meron pa. Sunod yun. Yan, meron sila mga oo.
They're probably fairly similar, but they maybe don't look that way because they're clustered together. But it's a lot of good engineering, huh?